The mic was muted. Okay. Well, I don't. Sometimes it's just stupid, I guess. Assign the oxidation numbers to all the atoms. Identify the oxidation and reduction processes. Write separate oxidation and reduction half reaction. Balance atoms other than O. Complete the following redox reaction. Give us both equation of oxidation and reduction half reaction of each equation minus the pH value. Assign oxidation numbers. Determine which atoms change the oxidation number. This identifies the oxidation and reduction. We separate into oxidation reactions. Balance each half reactions. Balance charge with electrons. Add the half reaction and simplify. What are the signs of a delta H delta S of a reaction? Why? So solid to gas, right? Gas is something having higher entropy. This is positive. Reaction between permanganate and oxalate and oxacidic. Where's the equation, bro? Oh, it's the same one, okay. Reaction between permanganate and oxalate in acidic conditions. Assign the oxidation numbers. Write the half reactions. Balance atoms other than H and O. Balance O and H using H2 or H plus. Instead of H plus, I think it's OH minus for basic reaction, basic condition. Balance charges by adding electrons, equalize electrons, and combine half reactions. Again, you made this 6 steps. I need it in 5 steps. Assign assign the oxidation half reaction. Write the oxidation numbers. Write the half reactions. Balance atoms other than H and O. Balance O and H using H2O H plus. Balance charges and combine the half reactions. Just a minute. We got a new algorithm. God damn it. Complex systems. Okay. Did you complete? We got to compress process in 5 clear steps by combining equalized electrons and combined with the previous step. Here's the clean 5-step version of the same reaction. So +7 to +2, +3 to +4. Right, they have reactions. Balanced atoms are then H and O. Reduction, both sides balanced. Balance O and H using H2O and H plus. Balance charges and combine half reactions. So assign oxidation numbers, write half reactions, balance at balance the half reaction, balance the reaction other than H and O. Balance O and H using H2O and H plus. Balance charges and combine half reaction. Yeah, I was doing this, okay. So MnO4 minus x plus 4 into minus 2 equals -1, 4 minus 2 minus 8, x equals +7. Mn has +7, now Mn is +2, +7 to +2. So +7 means it lost. +7 means it lost 7 electrons, and +2 means it lost 2 electrons. So that means -4 electrons. So manganese gained 4 electrons, so it's gain of electrons reduction. And so calculate the oxidation numbers and separate. Assign the oxidation number and separate. Assign the oxidation number. So MnO4 minus to Mn2 plus x, let's take Mn as x plus 4 times oxygen as an oxidation state or oxidation number of -2, with the overall it's -1, x equals +7, here x equals +2, -4 electrons. So magnesium gained gained these 4 electrons, therefore it's the reduction. Magnesium undergoes reduction. C2O4 2 minus to CO2 2x plus 4 minus 8 plus minus 8 equals minus 2. We take it to the other side, it's minus 6. X equals plus 3. And CO2 x plus 2 times minus 2 equals 0. X equals plus 4. So it's plus 1e minus. Lost an electron. So if it lost an electron, it's oxidation. So yeah, this is basically step 2. Assign the oxidation states, or assign the write the half reactions. Half reaction. So after writing the oxidation reaction half reaction, balance the atoms except O and H, oxygen, hydrogen. Step 3. So MnO4 minus to MnO4 is the same because there's no need of balancing. C2O4 2 minus needs 2 times CO2. Now, step 4, balance the H with H plus OH minus. This is for acidic, basic, and O with H2O. Exactly, in basic conditions you still balance oxygen with H2O, but hydrogen is balanced and using OH. For example, step 4, H2O to balance oxygen, OH minus to balance. Effectively, for every H plus you would have to add in a Okay. So balance the H and OH minus. So we have more oxygen on. So MnO4 minus, Mn2 plus how many oxygen? 4H2O plus 8H plus. close this window. Now C2O4. That's balanced. What the fuck? Now, balance charges oxidation. Why? Five electrons, okay. This is each carbon. So step 5, balance charges and combine half reactions. So balance the charges. Here we can see that magnesium lost gained 5 electrons. So if it gained 5 electrons, that means when it's in the reactant side, it did not have 5 electrons. So we add MnO4 plus 8H plus 5 electrons plus 4 H2O. Now in the case of carbon, the left side lost an electron when it got to the right side. So the right side is where it needs the electrons. So it, like this side it had 1 electron, this side it just lost the electron. So this is where we have to add the electron, the right hand side, and the 1 electron is lost per carbon atom. So we have 2 carbon atoms, 2 C2s. So C2O4 2 minus gives 2 CO2 plus 2 E minus. Now, before we add it, we have to maintain these things should be same. And 5 times 2, 2 times 5, 2 MnO4 plus 16 H plus 10 E minus, 2 Mn2 plus 8 H2O, 5 C2O4 2 minus, 10 CO2 plus 10 E minus. These should, now we combine the reaction. 4 plus 5 C2O4 2 minus plus 16 H plus 10 E minus, 2 Mn2 plus 10 CO2 plus 8 H2O plus 10 E minus. We could get rid of these E minus, and if there's H plus on the other side or H2O on this side, we could cancel those. This is how it's balanced. And these are the 5 steps to formulate the correct redox reaction in aqueous solution. The aqueous solution part, this is where the aqueous solution part comes in, where we fill in H plus and H2O. Oh, 30 minutes already? MnO4 minus plus C2O4 2 minus Mn2 plus CO2 acidic condition. So the first step is to assign the oxidation number. Second step, assign the oxidation number, separate the oxidation and reduction half reactions. All right, yeah. Balance the atoms with except H and O plus. Balance atoms other than H and O plus. H and O. Then balance the H and O with H plus and H2O, or OH minus and H2O depending on acidic or basic conditions. Then balance the balance charges and combine half reactions. Okay, come on. So we got a new question with write down the 5 steps necessary to formulate a correct redox reaction in aqueous solution. So before we do this, we have to remember a thing called oxidation state or number. And I'm gonna write the common ones. For example, for oxygen, it's usually -2. For hydrogen, it's usually +1. And there are other examples, but right now we're only needing these two. And the step 1 would be assigning the oxidation state or number. So we have magnesium MnO4 minus, which is we're gonna separate these two, magnesium and carbon dioxide. We're gonna separate those. So we're gonna write MnO4 minus and Mn2 plus. On the other side, we're gonna write C2O4 2 minus to CO2. Now, MnO4 minus, let's take the oxidation number of or oxidation state of magnesium as X, And oxygen, we have 4 oxygen, so 4 times oxygen, it was written that it was -2, 4 times -2 equals, there's a minus signs, that is what we're gonna write the whole thing is equal to. So from this we could calculate that x is +7. Now this +7 means magnesium has lost 7 electrons, or at least that's what I keep in my mind, that magnesium on the reactant side has lost 7 electrons. Now here magnesium has +2. So when it lost 7, at first it lost 7 electrons, then it only has lost 2 electrons. So that means it gained 4 electrons after being the products. So if it gained 4 electrons, that means it's gonna be the reduction half reaction. That's also the step 2. But yeah, if the compound or atom gained electrons, then it's gonna be reduction half reaction. Let's look at the carbon. It's 2x because we have 2 carbon, plus 4 times -2. Here it's 2 minus 2, yeah, which is going to be equated as -2. And after equating, the carbon would be +3, and here it's x plus 2 times -2. There's no number up here, so it's 0. X equals +4. So from losing 3 electrons, it lost 4 electrons. That means lost 1 electron. Losing electron means oxidation. At least for now, let's say losing electrons is oxidation half reaction. That would be step 4. Step 2, assign the half reactions, oxidation and reduction half reaction. Now let's move to step 3. Balance the atoms other than H and O. Just balance the rest, like magnesium, carbon. So what do we got here? MnO4. Right side there's no oxygen, but we don't have to balance oxygen, so we could just write it as it is. MnO4 minus gives Mn2 plus. In the case of carbon, the right side has only 1 carbon, the left side has 2 carbons. Therefore, C2O4 2 minus gives 2 times CO2. Now the carbon numbers are balanced. Step 4. Step 4 would be balance the H and O using H plus or OH minus. H plus is for acidic, and it's an acidic condition from what we've seen, and OH minus for basic. These are only used in the case of H and H2O. H2O is used for oxygen. So now what do we got here? There's no oxygen on the right sides, therefore MnO4 minus gives Mn2 plus. We need 4 oxygen, therefore we're gonna give it 4 water molecules. This is the part where aqueous solution or condition comes in. That's where we could given H2O and OH minus or H plus. So the right side has 4 oxygen but 8 hydrogens. So we're gonna balance the hydrogen using 8H plus. So there we go. And that now is balanced. But in the case of C2O4 2 minus and carbon dioxide, it's just already balanced. There's no H plus or O required. Now it's the last step and the most important step. We gotta balance the charges. The charges what is the charges we're talking about? These are the charges or the electrons we lost. I'll talk about that. Balance the charges and uh, combine the half reactions. Balance the charges and combine the half reactions. That's the last step and the most important step. So from what we've seen, magnesium from reactant to product, it lost 5 electrons. I'm sorry, 5 electrons. So it gained 5 electrons. I'm sorry again. So if it gained, this magnesium has 5 electrons more compared to the reactant magnesium. So we're gonna add, to balance that, we're gonna add this 5 electrons to the reactant side. That means MnO4 minus plus 8H plus 5E minus. That's the electrons plus Mn2 plus H2O. Yep, that's how balancing the charges looks like. Now, for the oxidation half reaction, the carbon on the left had 1 extra electron compared to the carbon on the right. So to balance that, we're gonna add 1 electron to the carbon on the right, the product side. So C2O4 2 minus. Oh, this 1 electron lost 1 electron. That's for single carbon molecule. We got 2 carbon molecules left and right. We got 2 carbon molecules, therefore 1 electron for each carbon molecule. That means 2 electrons, which is going to look like 2CO2 plus 2E minus. Now the charges are balanced, but before we combine these two, we gotta balance these charges. So what do we have to do in a way that we could cancel these charges? Multiply the whole reaction. It's like the LCM type sheet. We just gotta 5 times 2 is 10, so 5 times 2, the whole reaction times 2, and this, the whole reaction times 5. So 5 times 2, 10 electrons, 2 times 5, 10 electrons. That they're gonna cancel each other. So 2 MnO4 minus plus 16H plus 10E minus gives 2 Mn2 plus 8H2O and 5C2O4 2 minus gives 10CO2 plus 10E minus. Look at that. We got 10 electrons on both sides. Just add the reaction, combine 2 Mn. The reactant side should be on the reactant side, like the C2O4 and Mn, these things, they should be on one side. These two should be on the other side. So MnO4 minus plus 5C2O4 2 minus plus 16H plus 10E minus gives 2 Mn2 plus 10CO2 plus 10E minus. Those are cancelled. And if this 5 was 6 or something, we could have divided the whole reaction by 2, but this 5 is what makes it not work. But still, Wait, I forgot one thing. It was 8H2O. Yep. And this is the steps to balance a redox reaction, and this one is an acidic condition. My spelling, don't mind the spelling. Okay. So step one would be assigning the oxidation state number. And after that, when we assign the oxidation state number, we could see that which atom lost the electron and which one of those gained the electron. And the one who lost the electron would be having the oxidation half reaction, and one who gained would be the reduction half reaction. Then we balance the atoms without balancing the hydrogen and oxygen. This one is a simple example. That's why the oxidation half reaction did not even do add anything. Step 4, balance the hydrogen and oxygen. Yeah, we just balance it. Step 5, balance the charges. That would be an important step, because this part looks like we could just add these two, but no, if we should balance the charges. Only after that we should add the equations or combine the half reactions. Well, that's it. Peace. Devo, oh, yo, what's up? Devoto did appreciate Devoto did for checking out the stream. Where's the mouse? Okay. That one was done. I believe, yeah, I do know, remember the steps now. Complete the following redox reaction. Give also both equation for the oxidation and reductive. Ag plus HS minus plus CRO for, so Ag. Now this is where I fucking hate. I don't know the oxidation state of sulfur. And only after that you could write the answer, right? How do you know it's +1? Mute for just a minute. My headphones are not even charged. Go down. Mhm. Sign. This is what I hate. Again, I only know the oxidation state of what would I do when I see an element like sulfur? Sum of all oxidation state in neutral compound. Example HS. Let's oxidation state of S equals S. Okay. -2. So you found this. Let me take a. YouTube, I'm gonna refresh the chat because, you know. The fuck you doing, bro? So, from this, we could figure out sulfur is -2, then Ag2 2x. So from that, we figured out 0 to +1. Okay, so it lost an electron. That's oxidation. Okay. And CrO4 2 minus to OH3 -8 +6 -6. Oh, how do you do that? -6 plus 2. -6 plus 3. -3. So it went from +6 +6 to +3. Gained 3 electrons. Reduction. Okay, okay. What about S2? I don't want to look at that. S2O8 2 minus H2O. 16, 14, 7 plus 7 2 4 8 6 plus 7 to plus 6 still gained an electron. Oxidation. Now H2O. Whoa. H2O is oxidation? Oh. Plus 4. How? That's 8. You got. Okay. I guess that's what it is. I need to try doing this answer on my own. What are the signs? Let me see what DeepSeek did. There's three? Oh, that's the next question. Okay. Negative exothermic combustion reaction. What are signs? Why? Reaction forming CO from elements. Positive two solid one gas. Okay, that's only for that's only for entropy. More gas molecules, more disorder. Delta G at low T, delta G greater than zero. Delta H dominates at high T. At high TT, delta S becomes large negative. Wait, delta S positive. Uh, Even more negative. Actually, bro, this guy is fucking terrible. Vapor pressure depends on temperature of the liquid only, not quality, quantity, not surface area in closed container. I really thought surface area did had something. Okay. What is the maximum number of phases that can be in equilibrium? Three, right? Three. All these quantum numbers are permissible except when isoelectronic species are arranged in the order of increasing radius. What is the correct order? Oh, man. If it has a plus sign, that means it's a smaller atom. If it's a minus, it has more electrons, therefore bigger radius. Did they ask about reversibility? Okay, reversible or irreversible. You know what? I think I need to take a small break, about 15 minutes, cuz I feel a slight headache. It's not like a big one, it's a small one. But yeah, I'll take that break. I'm not going to end the stream. I'm just going to take a 15-minute nap. Come back. Yep, a 15-minute break. I'll be right back. Is there a set a timer for 15 minutes? Where is the jacket? Oh no. Where is my jacket? Zero. Oh, it's in the cold condition. Or is it? Yeah, I ate that. Cool. It's not in a really cold condition. One coffee could get me going, but I don't have coins to buy coffee. It's such a sad situation. Where's GPT? So if I start with the next question, complete the following redox reaction with Ag plus Hs minus plus CrO4 2 minus gives Ag2S plus CrOH thrice basic. So it's a basic reaction now. CrO4 2 minus gives CrOH thrice. Ag plus Hs minus gives Ag2S. So Crx plus plus 6, x plus minus 6 plus 3 plus 3 plus 6 to plus 3 gain electrons. So that would be reduction half reaction. X equals minus 2 for sulfur. 2x plus minus 2 equals 0. X equals 1. So it went from 0 to plus 1. Lost electron. Oxidation half reaction. Balance, now balance fast. So there is no, it's a basic, right? So CrO4 2 minus plus 3OH minus gives CrOH thrice. We go for 7 oxygen, 6 oxygen. No, 3 oxygen. For H2O, we got 3 plus 8, 11 H2O. 11 H2O and 7 O2. So if I put an 8 up here, it's going to be 8 plus 4, 12. why is the H2O on the left reactant side and the OH minus is on the product side? We're looking at the reduction half reaction. Cr4 to minus. Yeah, Cr is already balanced. Oxygen has 4O, 3O. We're in a basic solution, so we're using H2O, OH minus. On this, I thought we add H2O to the, as it has only 3O. You balance O by adding H2O to the side lacking H atom. Oh, okay. Three H2O. No. Two H2O. 3OH minus, right? We got 4. No. Mm-hmm. 5OH minus, that means 8. 4H2O, okay. Could you Yes, the difference comes from how we balance. Mm-hmm. Oxygen is balanced by adding H2O, and hydrogen is balanced by adding H plus. Typically, the water goes on the side lacking oxygen atom, which is often the product side. Here, H2O appears on the product side because oxygen from Cr3O72 minus combined with. Often you end up adding H2 on the reactant side because you're converting oxide ions into hydroxide ions and product side. Okay, I'll do the math with that. Now, if you're balancing the Ag plus Ag2, that means 2Ag plus Hs minus plus H2O plus OH minus. No, that's gonna be like 3. So 2Hs, 2Ag2, 4Ag plus 2H2O plus 2OH minus. No, that's not it. How did you balance that one? So weird. What the What did you just forget the HS? It's not balanced. It's not balanced. H plus what? Why did you just consider this as the half reaction? How many H? 8, 16, 16 plus 3, 19. 6, 16. No? I don't think it's balanced. Mm-hmm. Just a minute. It's getting harder and harder to focus. I don't know why. Is it too much phone? Using phone? Or should I change the subject? I think it's better if I change something. Uh-huh. I'll go cook. I still have to cook. I'm starting to get hungry. Maybe that's a reason. Mm, Yeah, I'll go cook something. I have something prepared. I'll just go cook that out. Peace out, YouTube, Twitch. I'm not gonna end the stream, but peace out, YouTube. I'll be back after cooking.